Hello everyone. I'm once again back with a very simple circuit. Basically two circuits, but it's a very simple latching relay on off circuits that I present here. This is very common. I'm sure this is available, several variants of this available in the net. Um, but the interesting part is with this simple setup, it's not possible to turn off once it is turned on. To do that, I have another circuit on the right, but let's start with the circuit on the left side. So the L1 is our relay. In my case, it's a 24 volt. I have a couple of them, so I use 24 volt relay and I supply around 24 volts. So the positive rail of the power supply is connected to the relay, but the negative rail is not directly connected to the relay, so it's off initially. So it goes through the center pole of the relay. So that's here in L1, this one. So this is the L1. Forget about the L2 for the moment. Just consider this part. So this L1. And the negative part is, as I said, connected to the center pole. That's this negative. Wire going to the negative crocodile clip here. That's the power supply terminals for me. And the other part of the relay is connected to the normally open position. That's this one, the normal open position. And once you momentarily push the circuit is complete. So you have the power going through the relay. So the coil is energized. The switch moves from NC to NO, and then it's on forever. Unfortunately, it's, as I said in the beginning, now it's not possible to turn off this circuit unless you disconnect the power here, or you use some kind of um, try to short the positive and negative terminal, maybe using a resistor or whatever. I tried that in the beginning, but you have 24 volts, so you would you would waste power in the resistor. That's clear. So let me show you how it works. It's not exactly one-to-one because now I've connected both the relays, but nevertheless the idea is very simple. So if you momentarily connect this one to the negative terminal, this would the relay would energize and to turn on. That's what I do here. So that's the normally closed position of this one. So now I connect it to the negative supply because I don't have a switch, so I just turn it on by this. So it should turn on, but why? Okay, found out there was a loose connection. So now if I turn on, I just have to connect it to the negative terminal. You see the click, you hear the click, and the LED is on. That's the LED that's connected to this relay. So I have a resistor here and it's connected to the power directly. So to turn off now, as I said, we have to switch off the power. That's what I do now. The whole power supply power is off now. And now let's go back to the second one. So as I mentioned in the beginning, I had a couple of these relays. I have several of them. So one way what I thought was to use another relay to turn this relay L1. I did not find any circuit like what I show here with two relays, but probably there should be something like that, or maybe some other variants. Nevertheless, it's a very simple setup. Let me explain. So this part is exactly the same. The L1, the negative is connected through the switch. So the NC is connected to the negative and so on. But the positive terminal of the L1 is not connected to the power supply. Instead, it is connected to the center pole of the L2. That's the second relay, this one, and it gets the positive power through the normally closed position. So it's normally before the L2 is energized, it's already closed, so you get the power through this position, through this normally closed position and the center tap. So the positive side is now established, or the terminal is connected indirectly. There is no problem. But to turn off, the trick is to use another momentary switch on the negative rail of the L2. So if you push this momentarily, what would happen is L2 would energize, so the switch would move from NC to NO, so thereby cutting off the power to L1. So it's a very simple trick. So just by using these two switches, S1 and S2, you could turn on and off the circuits. Of course, there would be a jump initially when once you connect it. So you have a relay now, so you should use a flywheel diodes, common things you should do. But I just show you a simple setup which you could use to control a lot of things. So it's in this circuit, it has a double pole, so you have the center tap on both sides. So you have, this is the normally open and this is normally closed. That's the same on the other side, and it's the same for the other relays as well. So the connections is quite simple, so you can see it one to one how it is connected. So this is the negative terminal of the L1, which is connected to the normally closed position, normally open position, sorry, this is connected to the normally open position, and the center pole is connected to the negative, so that's the yellow black wire. And in this case, I show, since I have two relays, I show this setup, but otherwise this should be connected to the positive, so there is no big difference. And in the with the two circuits, as you can see, the positive is connected to the normally closed position, like here. That's the normally closed position, and that's the center tap, and the center tap is connected to L1's positive terminal. So let me show you how it works. So this is for turning on. You should push this button. This is for the S1. Connecting it to the ground would turn on the LED. Oh, it's once again loose connection actually here, so it would turn on. And to turn off, you should momentarily push S2, that's this yellow wire. Connecting it to the ground would energize L2. You would hear the click as well. So you hear the click, this would turn off. So it's a very simple setup. You can do a lot of things with this. Since I had several of them, I thought of using multiple relays to control different things. So if you have any comments, if you have questions, please drop them on the comment section, and thank you for watching. Bye.